Good morning. Now, today I am going to talk about the chapter which is in fact from the Howler Variance Intermediate Microeconomics. This chapter is particularly talk about the demand, and in fact, this is in continuation of what we have done in the previous lectures. So, good morning, all. Let me come to the problem directly. And in the last chapter, what we have largely dealt with is actually choice and its optimality. Of course, this was being uh, together understood in the previous lecture, and today we are going to deal with the price change and how the demand is being understood. Of course, this is a part of the early lecture, as I said, and consider the two good case. Normally, it is given that you have an ordinary demand function as x1 star is equal to p1 p2 m, and x2 star also p1 p2 m, which is nothing but the demand function has a price of two commodity and the total entitlement, which is in fact give rise to how much quantity of commodity of x1 or 2 being demanded, and how does x1 changes as p1 changes, holding p2 and m constant. That is also going to be discussed in this lecture. Suppose only p1 increases from p1 dash to p1 double dash, and then to p. So then what is going to happen? So if you look really into this graph, it is quite clear that, see, you have a budget line which is nothing but p1 x1 plus p2 x2, which is equal to m. That is what is forms. So this p1 is equal to p1 dash. So where you have no change, that is your budget is the straight line, where you can say that either you can buy x2 commodity at a point which is in the y-axis to the top, or the complete income can be spent for x1, which is in the x-axis in the intersecting point. Now, if there is a change in price, that is when price changes, that is x1's price is in fact increases. So if it is shift to or down leftward, imply that p1 to p1 double dash imply that the price of x1 had gone up. That means there is an increase in the price. Definitely again then p1 double dash imply that there is again an increase in the price. So what does it technically mean? It is on the contrary says that the price of the commodity in that sense is being increased, and an increase in the price is in fact say that you become poorer. The affordability, poorer in the sense here is that the affordability of the commodity of x1 has in fact fallen, whereas x2 remain constant. Now that means totally if you go to the combination of x1 and x2, then you are going to be at a receiving end which is lower than what you had earlier. That is because precisely the x1's price has been increased, whereas x2 we haven't touched upon. So in that context, what is actually the whole point is that you become poorer, or your income is become fallen, or income has been uh, reduced. So this is what is actually in this case, and where you have an indifference curve, which is the initial one, which is x1 star p1 dash, which is nothing but the original one, the red line, the tangentiating point of indifference curve, with that of your budget constraint says this and star p1 dash. And now what happens if that forms your p1 dash x1 star on the right side, and then when you have a fall in the price takes place, that is in the simultaneous, that is if the price of the commodity, as I said from the earlier point, that is own price, that is from the red point to the yellow point, that means there is a fall in price, that is an increase in the price of there is an increase in the price, which is implies simultaneously P1 dash, which is results an x1 star P1 double dash on the right side of the angle. So it implies that a simple thing, when price of the commodity increases, quantity demanded will fall. So this is what is actually again depicted by the third price fall, that is P1 triple dash, which is again saying that the price has actually gone quite high, and then simultaneously the demand of the commodity has gone down. So this is in fact try to give us the relationship that the ordinary demand curve for commodity 1, saying that if the price is very high, quantity demanded of that price of the same commodity is less, and vice versa. If the price falls, then this is what is called the ordinary demand curve. In that sense, you have a price of a curve which says that, see, there is a line where your price on price case, which is a positive one, right? On the so the curve contains all the utility maximizing bundle traced out as P1 changes when P2 and Y constant is the P1 price of a curve. So this is what has been represented in the green of a curve, that is P1 price of a curve here. So again the plot of x1 coordinates of P1 price of a curve, again P1 is the ordinary demand curve for a commodity 1. So now ordinary means what? So this is the question which is going to be asked next, and a good is called an ordinary good if and only if, that is, a quantity demanded of it always increases as its own price decreases, and vice versa. That is, there is a negative relation exists, or holding all other factors constant such as price, income and preference constant, then the quantity demanded it always increases as its own prices decreases. Okay, so in that context, if you have a price of a curve in this case, that is, if the price of that particular commodity increases in the case, then we know that actually the quantity demanded subsequently for that commodity falls. So this is what is actually in the downward sloping demand curve says. So the red point is the initial price of the commodity, then the commodity the price has increased, therefore the quantity, and then the last point, that is the white point, says that the commodity price has gone so high, therefore the quantity x1 being demanded is so less. So this is actually when price rises, then quantity demand falls. This is what has been established, and vice versa. Now suppose if you start with the original position as your x1 is the first L point, then if the price falls, then naturally your demand for that commodity also increases. So when your price keep falling, then the quantity demanded is increased. So in that sense, in the same curve, you just keep on moving up and down, and this is what is called an own price changes and a resulting commodity demand. So this is what is actually something to do with this case. So if we go to the next part of the story, now a given good, so when I say that something is normal, it also implies that there are abnormalities exist. So if abnormalities exist, then what happens? Earlier when economists were being mapped all that, they had a view that commodities are all normal, that when your income increases, simultaneously you increases your consumption. So this is what is the meaning, or the quantity demanded also increases. Now this has been challenged. In fact it is not challenge, it was Giffen who found out that there are possibilities of a relation which is other than this. That is, even if the price of the commodity falls, people may not actually go and consume, and vice versa. Even if the commodity price has gone up, people still go for it in that sense. So the kind of thing in that context, it's very interesting. So given said that if the quantity demanded of a good decreases as its own price decreases and vice versa, that is, the quantity demanded of the commodity falls if the price falls, then you can say that there is a positive correlation. That positive correlation holding all other fact constant is called a Giffen effect in that sense. So now in the normal world, now you have an abnormal thing which is called the Giffen good. Now we need to hold other factor constant. Thus, if the price change is also associated with the change in income or preference, then if we there is a positive relation between price and quantity, it is not characterized as Giffen good. This is what has actually been discussed. Now, if suppose if we have the same, then what would be the shape of such an offer curve in that sense? So in this case, what we have to be seriously understood, that is, if the price has this sort of thing, then naturally you have a demand curve which is not necessarily earlier what I was trying to show is a convex inverse curve, that is negative slope curve. Now you have actually a positive slope curve, and sometime it's a concave curve. So I will come to that later. So let us look into this. See, suppose the original point is x1. Now suppose if you actually consume at that, and then the price of the commodity has gone up, what happens? In the normal case, it has to go. See, this is the case. Now, what is actually a kind of situation which we have to keep in that? You originally say that the price of the commodity was actually lower. Instead of going for the red line, what we have to look into is the white line. So the price of the commodity was, say, initially been set as white, that white dot. Now, when the price has fallen, what does it mean? When the price has fallen means there is a possibility of an increase, but that increase is not actually in that sense proportionate increase. There is a kind of you reduce your consumption of that good. Okay, so the rate is also going to reflect on that. So if you have a rate which is actually less than your commodity thing, then the fall in price is having actually leads to two type of possibility. Either this kind of good for a positive normal commodity, the fall in price is in fact having an effect, that is when the price falls, that means your income increases, so your consumption naturally increases. So in this case you have a consumption which is false, so the consumption also shrinks. So that is what been plotted here. It is actually sharply fallen, and then again it is going to, when your income again increases at a higher point, that just like the red tangentiated point, that means the price of the commodity has fallen very sharply. So that means your income increases. So even in that context, your consumption of the commodity is again going not that much in proportion. So this is actually gives you a kind of a positive slope. A demand curve has a positive slope part, and where your price of a curve is actually a backward bending kind of thing. So what does a P1 price of a curve looks like for a perfect complementary utility function? Again, that is going to be very interesting one. See, in the normal commodity, you know that there is a possibility of what you call the substitutability. But when you talk about the complementary commodity, what does it mean? It means that you cannot, even one commodity's price fall is not going to have an effect unless and until an equivalent amount of price complementarity takes place for the other commodity. Unless and until that happens, you will never increase or decrease your consumption, because of course you cannot afford, I mean, no longer you are able to consume if it is false, that is your price increases too much, so you will never. So what happens, your interest is actually makes you go out of it logically. But otherwise, if it is your income increases, still unless and until that increase compensates your possibility of buying the complementary, you will never actually buy. So this is an interesting way of understanding. So let's just discuss that. U x1 x2, which is equal to minimization of x1 x2, which is an equation which says that when you are x1 star p1m p2 m is equal to x2 star p1 m p2m, which is equal to m by p1 p2. So this is what is actually the equation try to make. What is actually it is going to have? So with the p2 and y fixed, higher p1 causes a smaller x1 star and x2 star. Okay, so what does it mean? It implies that, see, it's quite logical. That is, if suppose it's a commodity, that is, suppose your p1 tends to 0, that is, so you make the ceteris paribus assumption. So the other commodity's price is not going to fall or increase, so you keep constant. Okay, now the other commodity, that is the commodity which you are allowing that there is a fall in price. Now if that fall in price can be a positive one or a negative one. So if the price increases so much, then either you leave out because now your budget may not be helping you to buy it, or what happens is that, if it is increased, if the price falls, then your income increases corresponding to the level, unless and until the corresponding level which is complements the other commodity, you will never buy it. So this is a kind of situation. So p1 tends to 0, then x1 star is equal to x2 star, which implies that m by p2. As p1 increase tends to or infinite, then x1 star is equal to x2 star, which tends to 0. So this is what is actually the thing. Then what is actually an graphical representation of that is the following. That is fixed p2 and y, which is given in the thing. That is, normally this is what is actually called Leontief as the L-shaped curve. See, interestingly, there is nothing L-shape here. That is the whole point which we have to at least keep in mind. But there is a point inside what he is trying to make. Suppose if you are talking about the first point, that is, say, this point, that is actually you are talking about this point. Okay, suppose if you are talking about this point, then there is a combination of x1 and x2 at this white curve line. So only that combination makes you to basically, that combination only makes you to basically consume. See, if you have one more, suppose, what does it mean? You have a right pair shoes as well as a left pair shoe. Right shoe and a left shoe for in the paired manner. So what happens if you have one more left? So you cannot use that, because even if you can say somebody that okay, you can use this left pair, one day you can have an x1 left and say this is left and this is right. Okay, so one day you can have one left and the other one a day other left, and still you can, but the utility remains same. Though you have two things, you cannot actually use it together. Okay, and simultaneously you don't improve. When you can improve, if you get another pair of the thing, then you move to another level, that is a higher level of utility. Again, another point of view. So every time in the complementary case, what is your offer is the following, that you can have only this kind of thing, not the other commodities price falls and then immediately you can have. So what is normally we immediately understand is an inverse type of a curve, that is in the perfect complement case, the curve, the price of a curve is actually looks like an ordinary demand curve. Okay, so this is what is actually the kind. So but earlier case, whatever we have seen, in the ordinary goods you will get a positive curve in that sense. So when your price falls, then but in the other thing you will never get it in that sense. Okay, so you can only have the same thing if and only if. So this is what is understood in this case. That is, you can only have the pair, not one makes no sense in that sense. So what does P1 and P1 price of a curve looks like for a perfect substitute utility function? It is ux1 x2 which is equal to x1 plus x2. So it implies that x1 star P1 P2 m which is equal to 0 if P is greater than P2, P1 is greater than P2, and m by P1 if P1 is less than P2. And you can also have the same equation for x2, that is, you have if P1 is less than P2, then P2 m by P2 is actually if P1 greater than P2. Okay, so if that is the case, a perfect substitute thing is the following. Like, see, if a commodity is a perfect substitute, what does it mean? It is interestingly it creates a kind of interesting point. So suppose perfect substitute means what? So you have a combination of x1 and x2, right? And you have a price and budget. Normally we know. So initially we have a budget. Okay, say this is actually red one. So suppose if the price of x2 had increased, do the reverse. Suppose you have this yellow line. Okay, you have to make it. Now what happens is that x2's price has increased. x2's price is increased. Again, the red line only. The price of x2 increased. Now it is a perfect substitute. What is going to happen? Immediately, because of the nature of the substitution, you immediately transfer your entire consumption to this x1. See, that is what the red point, the x1 itself, because it's a perfect substitute. So the price of x2 increases, pushes to the consumption of x1 because it is a perfect substitute. So that is what is this point, that is x1 star is equal to m by p1 dash. Now if this is the case, then you have an horizontal one, that is, if this is the case, then no change. That is, in this kind of situation, perfect substitute, if there is an increase in the income, then immediately, if it is a perfect substitute, you substitute the same thing simultaneously for both the commodity. So this is what is actually this thing. Suppose if you consider the yellow line as your initial income, what happens if the x1's price has increased? So naturally you will consume x2 instead of x1, and you will have the white point on the other hand. Now this is the same thing which is actually interesting to say that suppose if you have an income of this thing, x2's price has fallen. So what you are going to do, you are completely going to shift to a new curve, which is your yellow curve, and that curve is going to give you a higher and higher level of utility. So what happens is that this is a kind of situation normally people try to understand as well as make. So you have an ordinary demand kind of this kind. So people have different inclination, different point. So you have a discrete point like this. So you have this again, this, and then you have another parallel point of that kind. So this is immediately makes you to completely substitute yourself from one commodity. So the normalcy will be actually going away in that sense. So I think this is relatively understood. So now you have actually other points like inverse demand function. Usually we ask, given the price for commodity 1, what is the quantity demanded of the commodity 1? So this is what is everyone asks. If 10 rupees is the price of apple, then what would be the quantity? How much if you have a given income, then you say that actually how much you are going to buy out of your income. This is what is called an ordinary demand curve, or what is called the demand function. Then you have an inverse demand function where it is actually your quantity being given but not your price. So what you are going to find out is your price. So quantity is given and then you are going to find out the price. So that is what is called an inverse function. So what could also ask the inverse question, that is, at what price for commodity 1 would a given quantity of commodity 1 can be demanded. So taking quantity demanded as given and then asking what must be price described the inverse demand function of a commodity. This is very interesting. Why? Because traditionally there is an issue that the demand is being treated as a dependent variable, and the price is an independent variable. No, in the equation we know that actually if the price is always been plotted in the y-axis, and demand has always been plotted in the x-axis in economics. So if there is a high price, then lower would be the demand. Then if the price falls, then higher would be the. So this is how normally we see. So there is an interesting inverse. But now people say that technically you see things are actually the reverse. Normally in mathematics, people try to always plot that your dependent variable is always on the y-axis and your independent. So there is a small change in that. So this kind of an issue can be actually a similar kind. So people would say that okay, what if the price increases and the quantity remains same, or what if the price influences the demand and vice versa? What if the quantity influences the price? So these are the questions which normally people can ask. So an inverse demand function says a given P1, what quantity is being demanded for commodity 1, X1. So now what is actually given is actually you have a P1, and then you can immediately draw that there is an X1 quantity. Okay. The inverse question is that you have an X1, so what would be the price of the commodity? So the reverse question is that given X1 dash unit are demanded, what is the price of the commodity 1? So answer is P1. So this is what is actually we are trying to understand in an inverse demand function. Very simple way of expression. So but the point is that if one commodity is given, that is one variable is given, then the other variable can be derived from the same thing. So if you have a common normal demand function is then the inverse demand function is also can be understood. So that means if your quantity being given, so if x1 is given, then x2 or y1 can also be derived out of it, and vice versa. If y1 is given, then this. So this relation is what is actually being normally understood here in a simplest simple sense. So now there are other issues like cross price effect. If an increase in P2 holding P1 constant, increase in demand for commodity 1, then commodity 1 is a gross substitute for commodity 2. So reduces demand for commodity in 1, then commodity 1 is a gross complement for the commodity 2. So this is another sort of an understanding in this thing. And then you have a gross substitute and complementary. Substitute if the price is higher for one goods, for higher good, you turn to buy other goods to give you satisfaction, that is drinks, bubble tea vis-a-vis fruit juice, entertainment, movie versus magazine, etc. So these are the kind of substitute. Complementary things tended to be used to together. So when one of the price increases, the demand for the other will decreases, etc. So we have already some camera and memory card, earlier camera and film, and now if there is no memory card, you cannot actually click any photos. So both are necessary in that sense. So cross price effect. If a complementary case, then you have an x1 star, which is the optimum quantity can be chosen by m by p1 plus p2. So you have a partial differentiation which says that your dou x1 star by dou p2 is equal to negative inverse of m by p1 plus p2 whole square, which is less than 2. Therefore commodity 2 is a gross complement for commodity 1 in that. So in that sense you have a price effect which is an inverse one. So increase the price of good 2 from p2 to p2 double dash, and again you have this thing. So increase the price of good 2 from p2 dash to p2 double dash, and the demand curve for good 1 shifts inward. Good 1 is in that sense a complement for good 2. So therefore, as I said in the beginning, that you cannot actually afford, because you reduces your consumption in that sense, because it's complementary. And for a perfect substitute, how will the quantity demand x1 changes when price of 2 increases? It only changes the point where x1 starts to be positive in that sense. So again, it is given that generally an increase in the price of good 2 from p2 to p2 double dash, and the demand curve for good 1 shift outward in that sense. So if your price of falls such a way, that then you can actually have an effect in this thing. Okay. Now, how does the value of x1 star p1 p2 m changes as m changes, holding both p1 and p2 constant? So this is how it has been changes. So I have already shown this income changes. So income has a income offer curve is positive in that sense. So a plot of income against quantity demand is called an angle curve. So this is what is an angles curve altogether. So income consumption curve is what is called an angles curve in that sense. So fixed p1 and p2, it is m dash less than m double dash is less than m triple dash. It implies that you have an angles curve the same, says what is actually from the panel left to the right, which has been. So this is two different commodity for x1 and x2, which can be derived out of the same combination. We can have this thing, and you can have two angles curve of good 1. See, the two angles curves and the slope and the proportions a little bit different, which is in fact a reflective of what is actually this combination is trying to say. So when income increases, the curve shifts outward for each given price if the good is a normal good. So see, that is what is actually happens when it is in the case of this thing. So now good for which quantity demand rises with income is called normal. Therefore a normal goods curve is positively sloped in that sense. So generally most goods are normal goods. A good for which quantity demanded fall as income increases is called an inferior good, which I have already said. Therefore, an income inferior goods angles curve is negative sloped. Example, a low quality food. Now, what is this low quality and all? We can discuss later. So, what would be the case? So, now by looking at the angles curve, you can say that what kind of commodity it is in fact. So, in the later case, what happens to the income of a curve of a normal good and the inferior good is this thing. So now Engels curve of this thing says the good 1. So income that is good 2 is normal, but relative to good 1 2, good 1 is actually an inferior, because the proportion of purchase of the commodity is actually lesser than the other commodity which is given in that combination. Okay, so income changes and perfect complementary preferences speaks next, and another example of computing the equation of Engels curve, the perfectly complementary case, which I have already said. So the ordinary demand equation also we have been seen. So suppose if that is the case, your Engels curve looks like m is equal to p1 plus p2 x1 star of good 1, and p1 plus p2 x2 star is actually the second commodity Engels curve. This is what is we have shown. All right. So it's also clear from the equation. Now Yeah, so it is all given. So if you want to have questions, we can have it later. Now when you have a perfectly substitutable preference, what happens is the following, that is y is equal to p1 x1 star. Suppose if it is a complete perfect substitute, so one price change, any change in that price you can completely shift towards the other commodity. Why? Because it is purely a perfect substitute. So why should you buy that commodity at a dearer sense, since provided the case that the price fall and will give yield you have a higher and higher level of utility, and also you will move therefore to the other commodity which is X1. So in that case you will never buy this commodity and go for it. So the normal commodities in that sense is very important. Now income, a non-homothetic example, that is quasi-linear. For example, many cases you can see that quasi-linear preferences. So like u x1 x2 is equal to f of x1 plus x2. For example, you have a utility of commodity which is given x1 and x2 such that x1 root plus x2. What does it mean? One commodity is linear and the other commodity is non-linear. So this is what is called a quasi-linear utility function. That is, for some point you have a linearity in that commodity. So you don't basically prefer that commodity, you move towards the other commodity which you feel that better. So then, and for that sort of a commodity or Ingalls curve, see, look at the Ingalls curve. You have in the first part of the curve, that is your x2 case, some point it, because of the linearity you go up, and then after that it becomes normal and you keep moving on it. And on the other side, this is the case. So this is the result. Now I think in the Cobb-Douglas case also you can have the same. So if the income and price all changes by the same proportion k, how does the consumer demand changes in that? So the question is obvious, and the same rate of inflation of the price and income. Again you have the same kind of an effect. So if you have questions in this case, I think we can take it up. So when it comes to the Cobb-Douglas case also, we can also discuss this thing very extensively. Else in the previous lectures also we used the same mechanism to understand it. So your u x1 x2 is equal to x1 alpha x2 beta is going to solve on your marginal rate of, so based on the marginal rate of substitution, which is equal to P1 by P2 and the budget constraint you will have. Yeah. So then the ordinary demand function of commodity, we have already seen in the previous lectures that A by A plus B times M by P1. So that is for X1's case, and the X2 case is also the same, by B by A plus B, that is alpha plus beta times M by P2. So this is, we have seen an own price effect inversely related to its own price, whereas cross price effect, no cross price effect for the utility. And the income effect, we have already seen the Ingalls curve is a straight line passing through the origin. So this is what is for an Ingalls curves kind of thing. So inversely related to its own price, and the other cross price is no cross price effect. These are the understanding or kind of an explanation which we can see when it comes to this Cobb-Douglas case. So now if you move towards this equation and apply the same, you will get this kind of a result. Okay. So income change and Cobb-Douglas preference, well, I have already said that. Okay. So you will get it. Now I don't think elasticity we need to really discuss, because it is nothing but the measure of percentage change of demand as results of 1% change in exogenous variable. But anyway, most of the elasticity is not so well, I mean, of course it is an important one, since most of this part been clearly dealt in the previous lecture, but still I would like to make a little rush through this thing, because not necessarily everybody was so well in this thing as a beginning point. So now you have an E, that is your E is elasticity is equal to change in xi with respect to xi time by change in pi with respect to. So this is pi xi by xi relation times dxi dpi. So this is what is being given. So cross price, this is what is called normally a cross price. See the dxi px. So this is what is, you have a cross price elasticity if your dxi by xi as here of two commodity, then your dpj by pj is equal to pj by xi and dxi by pj. Now income elasticity of demand is, in that sense you substitute the same thing with the income and the cross price elasticity commodity price of the other. So now if you have an ordinary good, your elasticity is less than or equal to 0. Now given good, your elasticity is greater than 0. Now gross substitute or your case is actually a greater than 0, whereas a complement it is less than 0. Now normal good I have already said, like greater than or equal to, which is actually comes to the income context. So income context, if it is the case for a normal good, when your income increases, then your responsiveness towards that commodity is also increases. That means it is always a positive one. For an inferior good, naturally it seems that when your income increases, your natural inclination toward that commodity falls. That means it will be less than 0. Okay. Price I have already said. Alright. Now to sum up the whole discussion, the consumer demand function for a good generally depends on price of all goods and income. And in the sense of analysis, you can make it as an ordinary analysis, and demand increases with own price. Given demand increases with own price, substitute demands increases with own price, and complement demands decreases with the other price. So normal good demand increases with the income, inferior good demand decreases with the income. So this is what is the whole discussion. Let me conclude these things. Thanks to you for listening this discussion. Thank you so much for your patience, and I think I will be winding up, and if you have any question, please feel free to ask.